All right. So you've given us this mountain of info on programming languages, how they evolved,
Right.
and well, get ready, folks, because we're going deep.
Okay.
We're diving deep through the history of how we went from, talking to computers in just ones and zeros
Right,
to
right.
these sophisticated languages that we have today.
Hmm.
We're going to be exploring some of the big names, like assembly, Fortran, C,
Oh,
Java, Python, of course.
cool.
But this isn't just a timeline. We're not just going to lay things out chronologically. We're really going full-on detective mode here.
Right.
We're going to figure out what problems each language solved
Yeah.
and why those problems mattered.
I love that. A detective story. That's a great way to think about it.
Yeah.
Programming languages, they really are kind of a fascinating puzzle.
Yeah.
And each one of these languages was born out of necessity,
Okay.
a response to the limitations of what came before.
So let's rewind all the way back to the very beginning.
Okay.
The era of machine code,
Right.
when programmers, had to communicate with computers using only ones and zeros.
Yeah.
What was it like working with such a basic system?
Well, imagine trying to write a novel. Just dots and dashes.
Oh, wow.
It's incredibly tedious.
I can imagine.
And that's really what it was like.
Right.
Every instruction for the computer, it had to be meticulously crafted using this binary code.
Wow.
It was like trying to build a house with just your bare hands,
Really?
brick by painstaking brick.
Yeah, yeah.
Just so much work.
That's a really vivid image.
Yeah.
No wonder they wanted to move on to something better. So
Oh, well, yeah.
yeah, exactly.
Yeah.
That brings us to assembly language.
Right.
Right.
That's right.
So tell me what made it such an important stepping stone in this whole evolution.
Assembly language, I think it's kind of like, imagine you're building that house, right?
Yeah.
And suddenly you get a basic set of tools,
Okay.
a hammer, a saw.
So it's not just your bare hands anymore.
Exactly.
Oh.
Assembly language, it introduced these things called mnemonics, which are basically short codes that represent instructions.
Okay.
So instead of writing like 0010101001, which might mean add these two numbers,
Right, right.
you could just write ADD, which is obviously a lot easier for humans to read and write.
Right. I mean, that makes sense.
Yeah.
Um, but why was it so important to make programming easier for humans?
Yeah.
I mean, wasn't the goal to make the computers do what we wanted?
Well, yeah, but that's the key insight.
Okay.
You see, the bottleneck, it wasn't the computer's ability to process information.
Okay.
It was our ability to give the computer instructions quickly and accurately.
Right, right.
So by making programming more accessible,
Yeah.
it meant that more people could contribute to this whole, emerging field of software development.
So it was about unleashing human potential,
Yeah,
not just the potential of the machines.
that's a great way to put it.
I like that.
Yeah.
And this need for better tools, it takes us to Fortran.
Right.
Right.
Yes.
So what made it so special besides its awesome name?
Well, Fortran, it was really designed for scientists and mathematicians.
Okay.
It was all about handling these really complex calculations.
Mhm.
Think about like the early days of space exploration,
Right.
NASA, they used Fortran to calculate satellite trajectories. Without it, putting a man on the moon would have been, far more difficult, maybe even impossible.
Wow, that's amazing. So Fortran is like the hidden hero of the space race.
You could say that.
I never knew that. Yeah, it played a huge role. This drive for efficiency and power, it kind of brings us to C.
A language that's, it's still really widely used today.
Yeah, C always seemed like kind of a big deal, even though I don't really understand what makes it so special.
Right.
Can you break it down for me?
So C brought this concept of portability to the forefront.
Okay.
Imagine you write a program for a specific computer.
Right.
Back then, you often couldn't run that same program on a different type of computer without having to rewrite huge chunks of it.
Yeah.
But C allowed programmers to write code once
Okay.
and then run it on different machines with maybe just a few like small modifications.
Oh, I see. So that meant that software could be developed a lot faster
Yeah,
and cheaper, I imagine.
exactly.
And it probably led to a lot more innovation,
Absolutely.
since people could share their code more easily.
Yeah, you got it.
So it had a huge impact.
It did.
What sorts of things was C used for?
Well, it became the building block for operating systems.
Okay.
Like Unix and Windows,
Well-
and then countless other, essential software applications.
Okay, so we've gone from hand coding and binary to these powerful, portable languages like C.
Yeah, it's been quite a journey.
It has.
Right.
So what happened next?
Well, the rise of the internet
Right.
created a whole new set of demands.
Okay.
And that's what brings us to Java.
Java. That one rings a bell.
Yeah.
It seems like every website back in the day was using Java for something. What was it about Java that made it so popular for those web applications?
Well, remember how C made software more portable across different types of computers?
Yeah.
Java kind of took that idea a step further with
Yeah.
this philosophy of write once, run anywhere.
Yep.
So you could write a Java program,
Right.
and it would run on any device that had this thing called a Java virtual machine, which is basically like a translator for different operating systems.
Oh, Java made sure that everyone could access the same content on the internet.
Exactly.
Like,
It was perfect for this, rapidly evolving and diversifying landscape of the internet.
It really was. I mean, of course, we can't forget Python.
Right.
What's fascinating about Python is how it's managed to be both beginner friendly
Mm-hmm.
and used for these really complex things,
Yeah.
like artificial intelligence and stuff like that.
Yeah, it's pretty incredible.
It is.
It is.
So how does it manage to do that?
Well, Python is all about readability and versatility.
Okay.
Its syntax is very close to a human language,
Right.
which makes it easier to learn and understand.
Yeah.
But don't be fooled by that simplicity. It's a powerhouse,
Yeah.
People use it for web development, data analysis, machine learning, all sorts of stuff.
So we've come a long way from machine code to assembly, Fortran, C, Java,
Mhm.
Python.
Mhm.
So what's next?
That's a great question.
Where are programming languages headed in the future?
Well, one trend that I think is really interesting is this idea of language interoperability.
Okay.
So imagine a world where different programming languages can kind of talk to each other seamlessly.
Right.
Like different instruments playing in perfect harmony in an orchestra.
That would be amazing.
It would, wouldn't it?
Yeah.
We're also seeing this rise of domain-specific languages,
Okay.
which are languages that are basically tailor-made for specific tasks,
Right.
like designing video games
Oh,
or controlling robots.
oh, wow. So it's getting even more specialized.
Yeah, I think that's definitely a trend that we're going to see more of.
So we've gone from the equivalent of like banging on drums to composing these intricate symphonies with software.
It's pretty amazing, isn't it?
It is.
When you think about it, how far we've come.
It really is.
It's an exciting time to be in this field, that's for sure.
It is.
And I think that's something that's worth pondering for all of us,
It is.
What's next?
Yeah.
What are we going to build?
What are we going to create?
Yeah.
It's exciting.
It is.